so today we're going to be looking at section 3.4, application problems. So the problem-solving process. Most of the mathematics, the purpose of it all is to basically make sense of the real world around you through writing equations and models that mimic those. So to actually go out and do real-world problems is what math is for. There's a lot of ways to do problem solving. Here is one technique that has been culminated by a lot of famous mathematicians over the years, and it's a 4-step process. And the first step is probably the most important one, and it's understanding the problem. A lot of times people will read a problem and they don't understand some of the words in it, but then they still try and solve it. You have to understand the entire problem. Okay? So the first thing you want to do to understand a problem is you want to read it. You can read it several times if you need to. Make sure you understand the meaning of each term or word that is used in the problem. If you don't know what a word is, you can't answer the question properly. In the course of reading it, try and identify what it is you're asked to find. Identify the information given to you in the problem. So this is your preliminary reading and making sure you understand the words. Okay, and what you're trying to find, things like that. You're starting that process. The second step is you want to develop a model of the problem. Draw a picture. You can actually draw the picture up here in the understanding part if it helps you understand the question. Drawing a picture is a good thing to do. Visualize yourself as a person in the story, so be part of the story. Okay, you have life experiences. Use them to your advantage. The next part here is how we start getting our information gathered up. Organize your information. Most of the time we use a table. If we don't use a table, we could be looking for formula words, words that talk about area, volume, distance, things like that. Okay, so if you see those kind of words, there's usually a formula associated with it, and you're going to use that formula in the process of your problem. So you want to make sure you understand those words. You want to identify the thing you're asked to find, introduce a variable to represent the quantity that you seek. There could be more than one. You don't need just one variable. As you get up higher math, you could be identifying more than one at a time. It just depends on your situation. Identify information that you need to find. What are you asked to find? These are things that you want to be looking for. Use the statement of the problem to find an equation or inequality that relates the variables you seek to the quantities that you know. In other words, find an equation or a rule, if possible. Once you have all that, you want to solve algebraically, if possible, and or support graphically. Okay? So you're trying to display your work at this point, so that when somebody looks at your work, they understand what you're doing. If it's possible to do, it's okay. You can solve just algebraically, that's fine. You can just solve graphically, sometimes that's fine. Sometimes you can just do it numerically, that's just with a table. And sometimes in situations, that's fine. Sometimes you want to do two processes, show me algebraically and graphically to display your information. And a lot of that will come around because they'll tell you certain things, and that will give you the clues that you're looking for. And sometimes you just want to display your answer because there's a lot going on. Try to avoid solving graphically and numerically as your sole method, because there's no, let me put it differently. Solve graphically and numerically if you can't solve it algebraically. Okay? Algebraically will give you an exact answer. Graphically will give you approximate answers a lot of times. Numerically, it takes a long time to find. So if you rely on these solely, it could be, you're not going to get really the best answer that you're looking for. So you really want to do algebraically and then support with these two. But if you can't solve algebraically, then use these two methods as your sole means for finding a solution. Once you have found a solution to whatever it is you're looking for, your model, your equation, Make sure you're answering the questions. Interpret the solution to the problem. Just because you find a solution that says x equals 3 doesn't mean you've answered the question. Go back, right? Identify what you're asked to find. Make sure your solution that you have actually answers what they're looking for. Okay? And does your answer make sense? A lot of times people get an answer and they say, oh, there it is. Like, how long does it take you to, grow a tree? And you get an answer of -4. Okay? Well, that doesn't make sense. How do you get a time of a -4? So make sure your numbers make sense to the problem. So again, this is just a guide to kind of walk you through a process, what to think about along the way. There's many things here that you got to look at and get used to using. And again, there is no one particular way of doing problems. The best thing to do is you get experience by doing problems. When you get stuck, go back and look at this and say, okay, did everything I was supposed to do? Do I really understand the question? Things like that. All right, so let's go ahead and do some problems. We're going to do some of our classwork problems. So in this worksheet right here, we're going to try and answer some of these as many as we can in the time that I have. So problem number 1. So what do I want you to do? Write an equation that represents the information, find a solution, and then use your solution to give a reasonable answer to context. A jet flies at an average speed of 540 miles per hour. How long will it take to fly from Fresno, California to Sydney, Australia, which is a distance of 7,512 miles? Okay, so we read this question right here, and we look around and we say, okay, well, what can I do for this? There's a lot of things you can do. We're supposed to find a rule. Now, there is a formula word in here. If you did not notice it, distance. This is a distance problem. So there is a formula for distance. If you knew it, you can use it. The distance you travel is equal to the rate times the time. How fast you're going and the time it takes you to do it. Because I noticed I had a distance, I had a formula word, I write the formula down. Then I can use the formula to get my equation. Do I know the total distance? Yes. Do I know how fast I'm going? Yes. Do the units match? Make sure you always check to make sure units match. You can't have miles per hour and down here in kilometers. They have to be the same units. If they're not the same units, you would have to then change to the same units. But these are all the same. So I want to find how long it takes. That is a time reference. So we plug in the information we know. 7,512 miles is the distance. I'm going 540 miles per hour and times the time, and there is my equation. So I've used a formula word to help me write my equation. So very useful technique. Then what? Well, then we just solve this for t. So I'm going to divide both sides by 540. So divide both sides by 540. And I get t equals 7512 divided by 540. That is the exact answer. You can reduce this answer. If you reduce it down, you're going to get 626 over 45. That is a fractional answer, and it is in hours. So your units of measure are in hours. But that really doesn't really make sense to me. I mean, 626 divided by 45 hours. So, but that's the exact answer. If you type this into a calculator and get a decimal version, you would need to round your answers to 3 places. And because you're rounding your answer off, it's now an approximation. It's not exact. This is exact. And this is 13.911. And I rounded it off to 3 decimal places. which is your default. Your default rounding is always to 3 decimal places, please. Unless it's money, then that's 2. So this means about 13.9 hours. Okay? So let's answer the question. How long will it take to fly from there to here? You can leave it as 13.911 hours. Or you can also you can even kind of like say about. So in answering the question, I use the question to answer the question, which is, it will take about or close to 14 hours to fly from Fresno to Sydney. That's me answering the question they asked. I can also just put in here, it will take about 13.911 hours. So I can use that round off. I approximated it to that. It probably would have been better if you used that, but that's okay. As long as I see these values, I'm okay with your answer this way. So that's one using a formula word. What's the next one using? Here, I give you information in the table. This is the height of a hang glider. 15 minutes after beginning a descent. Find the height of the hang glider after 7 minutes. And I give you this information right here about the height. This is the number of minutes, and this is the height of the hang glider. So I gave you variables to use, so you use the variables they gave you. This is in minutes, this is in feet. And so you can transfer this to our work page. This is organizing your data, which they gave you, into a table. So I have T, which is in minutes, and I have H, which is in feet. And this is what I had on here: 0, 1, 2, and 3, and 2100, 1875, 1650, 1425. And so what is the process we use if I have a table? I want to find a rule. Well, what kind of rule am I going to get? I don't know. Let's find out. That's a +1. And if I subtract those, or the process from here to here is minus 225. Does that hold true the whole time? When you're doing a problem from scratch like this, you need to make sure that it's the same all the way through. Don't assume. In this case, though, it is indeed same. Well, based on our knowledge, this is the rate of change. The rate of change, so in this case, H and T, the change in the H's divided by the change in the T's is a negative 225 over 1, or a negative 225 feet per minute. That right there. Well, that's a slope. Changing the values is a slope. That means this thing is descending 225 feet every minute. So how do I write the equation of a line? It's a common difference. The same rate of change each time, so it's linear. So I need a point and a slope, and that would be my slope. So I have H is the variable. Normally we have a Y, but we have an H this time, correct? And then pick a point. So I'm going to pick that point right there because that's the best one. If you got 0, that's the best point. Minus 2100 equals the rate of change times T, because there's no X, it's a T in this time, minus that value. And so then I get H equals a negative 225 times T plus 2100. And that is my model that they're looking for. Since I have the model, the next step is, what is the height? So at T equals 7, what is the height of the hang glider? So I just simply plug in 7. And you can type that into calculator, and you will get 525 feet. And so you can write your final answer here. The hang glider will be at 525 feet after 7 minutes. Answering their question. Could I have done this with just the table? Except for the fact that the directions told you to write an equation. If I was just trying to solve this problem, could I just extend this table? I could have. By extending the table each and every time until I got to 7 minutes, I would have had the same answer of 525. Okay, so that's the numerical approach to this problem. Okay, let's look at number 3. You have a piece of wood that is 84 inches long. You cut the wood into 3 pieces. The second piece is 6 inches longer than the first. The third is 6 inches longer than the second. How long is each piece? So the best way to approach a problem like this is to draw a picture of it. You have a piece of wood. Okay, visualize a big 2x4 or something. So draw it. Here's my big piece of wood. I'm going to cut it into 3 pieces. So that's what it said to do. So I'm going to divide this into 3 pieces, and I'm not going to make them the same length because they're not going to be the same length. So I'm going to make them different lengths. This is the first piece, and then the second piece is going to be a little bit bigger, and the third piece has to be bigger than that. So this is the second piece, and this is the third piece. All I'm doing is just drawing out what it's telling me. I know that this right here is 84 inches long. I'm in the understanding phase still. Do I understand what's going on? Put myself in the problem. I'm the guy that's cutting the wood. What do I know? I know that this piece is 6 inches longer than that one, correct? And I know that this piece is 6 inches longer than that one. So really, to write something to represent this, it says pick a variable to identify what you're looking for. So since all of these are based off of what the first one is, I'm going to pick a letter. For some reason, I chose W today. And I'm going to say W is the length of the first piece. And I write that down. This way, when I come back, I know what it is that I'm doing. So that means the first piece has a width or length of W. Going back over the problem a second time, the second piece is 6 inches longer than that. So this is going to be in inches. So then this would be 6 inches more than that, which means this is the W plus the 6. 6 inches more than that. And then this piece over here is 6 inches more than that one. Well, that one is this, and then I'm going to add another 6. By drawing this picture out, I kind of get a feel for what's going on. The whole thing is 84. So this piece plus this piece plus this piece must be 84. And that's how you can find your rule. So W plus 6 plus W plus 12, on like terms, must equal 84. And then I can solve this equation. This is my model. I have 3 W's. 6 and 12 is 18. And then just go through the process of solving this out. So we're going to subtract the 18. 3W is 66. Divide by 3, and W is 22 in inches. So this is 22 inches. So with that, I should be able to go back and answer this question. The question is, what is the length of each piece? So the first piece is 22 inches. The second piece is 6 more than that, or 28 inches. And the third piece is 6 more than that one, so then that would be 34 inches. And you can look clearly here that if you added these up, you would indeed get 84. So there is your answer to that question. Let's look at question number 4. Kind of an interesting question. It's really blurry. I get it to focus again. Not quite. All right. A truck's fuel efficiency is 18 miles per gallon on the highway and 14 miles per gallon in the city. The truck uses 26 gallons of gasoline to travel a total distance of 448 miles. How many gallons of gasoline are used in the city? Okay. So in understanding this problem, let's write down the stuff that we know. So in question number 4, what do I know? Well, I know that I'm traveling on the highway. And I know that I'm traveling in the city. On the highway, I get 18 miles per gallon. In the city, I get 14 miles per gallon. I know that I use a total of 26 gallons. And I travel a total of 448 miles. This is the information that they give me. So we have to think about our experience and see how this works. I can make a table for each the highway and the city. How would I do that? Number of gallons for the highway. If I spend or use 1 gallon, according to 18 miles per gallon on the highway, if I go 1 gallon, then I have gone 18 miles. If I use 2 gallons, then I go what? 36 miles. And so forth and so on. I can do the same kind of a table for the city. Number of gallons, city travel, 1 gallon, 14 miles, 2 gallons, 28 miles, and so forth and so on. And I can continue this until what? I can go, I got 26 gallons. So I'm trying to find these distances that will add and equal 448. Is what I'm trying to get to. Okay. So there's a cut. I can continue this until that works, and just kind of you're doing a numerical approach to it. Okay. I can also look at it in a more algebraic approach. Since I'm asked to find how many gallons I have in the city, I'm going to pick a variable. I'll call it G, and G stands for the number of gallons used in the city. That's what G stands for. Because I know I've used 26 gallons. If I use this many gallons in the city, how many gallons did I use on the highway? Let's think about that for a minute. If I use 2 gallons of gas in the city, and I know I spend a total of 26 gallons, then I must spend 24 gallons on the highway. If I spend 10 gallons in the city, then I must have done 16 gallons in the highway. So what I'm doing here is I'm just take whatever this number is and subtract it from 26. So if this is the number of gallons in the city, then 26 minus that value is the number of gallons used on the highway. And that's a concept that I want you to understand that you can do. If this is how many is in the city, then whatever's left is used on the highway. Because then this allows me to do this rule, which is a very common kind of a rule for you. You get 14 miles per gallon in the city, and you spend this many gallons. So if I take the 14 miles per gallon and times it by the number of gallons, then I can tell you, just like we're doing here, number of gallons, how many miles I've gone. That's what we're talking about here. That's how we got that. If I take that and so this is the number of miles I travel. If I do the same thing for the highway, 18 miles per gallon, and that's the number of gallons I use, then this is the distance I traveled in the city, this is the distance I traveled in the highway, and the total distance has to be 448 miles. And so then that gives me my model right there. I can then solve this model for G. And 14G, distribute this out, and we get 468 minus 18G. It's 448. Combine like terms. Move the 468. I get negative 4G equals negative 20. And divide by negative 4. And G equals 5. So what does that mean? Five gallons of gas was used in the city. And that was the question they wanted you to answer. How many gallons were used in the city? So that's what's going on those. Here's question number 5. The first story of a building is 22 feet high, and each additional story is 16 feet high. Write an equation for the total height of the building to the top of the nth story. And then explain the meaning of each thing in context. So there's a lot of ways to do this one. To me, I would draw a picture. If I needed to understand this question more, the first floor, this is 22. Then I put another floor on. That's 16. Then I put another floor on. That's 16. If the idea was happening, so you can see what's going on, each of these after there is 16. I can take this and put it into a table once I saw that. And the table I can use would look maybe something like this. We want to base off the number of floors. So N is the number of floors on this building. And H will be the height. If I have one floor in this building, it is 22 feet tall. But it said the first floor was 22. If I have 2 floors on the building, then it is, now look how I do this. I don't really care what the actual number is. I want to see how I get the number. The first floor plus the 16. If there's 3 floors, then it's 22 for the first floor. And then what? 2 16s. So I would write it as 2 times 16. If there's 4 floors, then it's 22, and then 3 16s. I do it this way to see if I can establish a pattern. Because if the next one here is in, then how do I get the height of the building? 22 plus, now, the 16 was staying the same, correct? So it'll be 16 times, then what? 1 less, right? Because the first floor is already set. We're taking that first floor out, aren't we? If I have 20 floors, then only 19 of them are 16 feet tall. So it'll be n minus 1. And that's how I can get my rule that way. The height of the building is 22, 16 times n minus 1. This is the height of the building. And the n right here, the n itself is the number of floors. And there you go for 5. Okay?